when you're trying to look at your graph and you get some sort of dimension error, probably go into your y equals. Oh, I got to quit this first. Go into your y equals. You probably have something saved. I didn't, but that is the most common thing as to why it doesn't show your graph, is because you have something graphed. So do your stat plots need to be off? Good question. And I'm going with, it certainly doesn't hurt to turn them off just in case that is the issue. But I know for certain that having something saved in your y equals from another problem you've done is often the issue. So let me go back into my test and see if it will plot. Okay, that very likely was the problem, whatever was in my stat plots. I don't think it's necessarily having your stat plots off as what the dimensions of whatever is graphing is. If I had no data in my lists, it wouldn't matter if my stat plots were on. So when you draw a t-test, you are always going to get a normal distribution curve. And what it is showing you, there are values along that axis. And right here where your shading starts is your t-value. And then, so there's our negative 0.82. So it makes sense that it's negative because it's left of the x equals 0. But our table value falls somewhere over here. If your table value falls in the shading, then it is not significant. Okay, but we wanted to look at if you enter your lists. So if you need to enter your lists, go to second memory. Oh, and when you draw it, it's going to show you your T and your P down there. And if you hit trace, no. Okay. See, I hit trace, and so I can go over to X to show where our value is. And our table value was 1.67. So our table value is way over here. So our table value is clearly in the shaded region. Okay, but to clear our lists, second and then the plus, that's second memory, and 4 to clear all lists. Okay, number 4 asks you to enter data, and I copied and pasted the data there. Okay, so you would go into then stat and edit and enter your data. You have 4 servers to compare. So enter server 1 in list 1. Server 2 in list 2, server 3, obviously keep going. Okay? I'm not going to enter all of the data. I'm just going to enter the first line, 1 and 2, just to give you an idea of what you're doing. Now, you notice all of these servers do not have the same number of data points. That does not matter. It doesn't matter that your lists are different lengths. Okay, so I have some of the data put in. I did not put all of it in. Okay? Now, when we go into stat and tests this time, we still pick the 2-sample t-test, but this time we're not doing stats, we're doing data because we entered our data into list 1 and list 2, list 3, list 4. So what you have to do is you have to fill in the chart. So it asks you to test 1 and 2. So you would leave list 1 and list 2. Leave the frequencies as 1. Now, which of these are we doing? Not equal, less than, greater than, which one are we doing? It tells you not equal because it specifically tells you a 2-tailed test. Okay? You leave data not pooled, and you can just go ahead and draw it if you want, because drawing it not only gives you the picture, and you can already see right away we've got some shading, but we don't have much shading. So based on the shading, do you think there's a significant difference between these two? Yeah, there's not a lot of shading. So remember, it's a 2-tailed test. So look what happens. You get symmetrical shading on both sides. Okay? Now, usually, there we go. There's the T. There's the P. You would look up the T based on your sample numbers. Remember, I did not put all the data in. But if we are testing a 0.05 level, look at my P. What would we say about this data? Significant, yes or no? That says 0.03. So this would be a significant difference because P is less than alpha. So the probability of error is less than the alpha, the level of error we're willing to do. Now, you should look up your critical table value for these, but I can't do that because I didn't put in the right number of samples. But I could look it up for the samples that I used. So if I look at my lists, I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 7 plus 8, I have 15 degrees of freedom. So 15 degrees of freedom for a 2-tailed 0.05 would be 2.134, and my T value was greater than that. So you always want to check your T versus your table value and your P versus your alpha level to make sure that they're giving you the same information, because if they're not, there's probably a mistake further back. So then I would go into my stat test number 4 again. I picked the wrong one. Try again. There we go. This time I need to compare list 1 with list 3. So my list 2, I use second 3 to get L3. Everything else stays the same. And again, calculating or drawing is going to give you all of your values. Remember, you're going to get shading on both ends if there is any shading. We've got some shading so far, but we had some shading on the last one and it wasn't much. Getting a little more shading this time. So the first graph had very little shading. So from the graph alone, we were thinking it was probably a significant difference. This, we've got to wait for the numbers. Okay, so my critical table value was 2.131. How does the t compare to 2.131? It's less than. My alpha level is 0.05. How does the p compare with that? It's greater than. So I fail to reject my null hypothesis. So I reject my alternative hypothesis. There is no significant difference between these two samples. Okay, so this practice set is due next Monday. You should have time Wednesday to work on it with your group.